Hi, welcome to pantechelearning. Digital learning is simplified with happy learning. Myself Radhika, I'm going to explain simulation project based on Matlab Simulation Blocks. Now let's learn the project about simulation of speed control of brushless DC motor in Matlab Simulation Blocks. We also can do the same simulation project in hardware. For that, check the description box below. We also provide free webinars and various courses on various domains. To get more information, subscribe our pantechelearning channel and get updated notification daily. Now let's see the concept about this project. First of all, you will see the agenda of this project. First, we are going to see the introduction to brushless DC motor, and next we will see the speed control methods of brushless DC motor. Next, we are going to see overview model of the brushless DC motor, and next working, and we will analyze the output waveform. So first of all, what is brushless DC motor? So basically, brushless DC motor is also known as one kind of the electronically commutated motor, or this type of motor that operates using a direct current, but it does not use brushes and commutators like other than traditional DC motor. Instead of this, it employs some electronic control to manage the commutation of the motor phases, which makes it more efficient and reliable, and also the maintenance free compared to the other brushed DC motors. So first of all, it contains the stator part and rotor part. So stator part is the stationary part of the motor that contains the motor windings, which are typically arranged in three phases like A, B, C. Next one is the rotor part. So rotor part also is a rotating part of the motor. It can be equipped with some permanent magnets that only creating the magnetic field. So this interaction between the stator's magnetic field and the rotor magnetic fields that will generate the torque that causing the rotor to rotate. So this is the main part of the brushless DC motor. Next one is the commutation process. So the traditional DC motors, brushes and commutators are used to change the direction of current flow through the windings. So which creates the rotating magnetic field. So in brushless DC motor, here electronic commutation is used. So where the direction of current flow is controlled by an external controller based on the rotor's position. So this is the basic introduction about the brushless DC motor. So I have to tell one thing. So this brushless DC motor is often having a Hall effect sensor that will be mounted on the stator part. So these sensors mainly to detect the rotor's positions by monitoring changes in the magnetic field. So this information is sent to the motor controller part, and that will determine the appropriate phase currents and timing for the commutation purpose. So next one is the speed control of brushless DC motor. So there are a lot of methods. One is a voltage control method, pulse width modulation method control, and sensor-less control, sensor-based control, open loop control, and closed loop control. So now today we are going to see the voltage control. So this is our simulation model. So we have to increase or decrease the voltage, we are going to control the speed of the motor. That means the brushless DC motor. So here I have to use one universal bridge rectifier, and this is our brushless DC motor. We have to change the voltage. We are going to control the speed of the motor. So this is our simulation model, and this is our output waveform. We are going to open the Matlab software here. This is our simulation model. So here I have to use one DC voltage source, and this is a universal bridge rectifier, and this is our brushless DC motor, permanent magnet synchronous machine. So here this Hall effect sensor. So this Hall effect sensor that is mainly used in a brushless DC motor to determine the, as I said earlier, to determine the rotor position. And this rotor position provide feedback to the motor controller part. This motor controller uses some feedback to control the switching of the motor phases in a way that generates a recovered rotating magnetic field. So this process ensures that motor rotates smoothly and efficiently. So here we have to use one universal bridge rectifier. So this only responsible for delivering the appropriate voltage to the motor phases based on the Hall effect sensor feedback. So I will tell you in a detailed manner. So here there are 3 Hall effect sensors that placed in at equal angular distance around the stator part of the brushless DC motor. So these sensors mainly used to detect the rotor's position. That means position of the rotor's permanent magnets and determine which phase winding is currently in the most favorable position for energizing. So this is the main thing in a speed control of brushless DC motor. So each Hall sensor, so here you can see each Hall sensor will give you some digital signal that indicates the state of the magnetic field at its some specific position. So these outputs are typically referred to as the Hall A sensor and Hall B sensor and Hall C sensor. So this is our output. So this motor control uses these Hall sensor outputs to determine the correct sequence for commutating the motor phases. So depending on the combination of the Hall sensor outputs, the controller identifies which motor phase should be energized next to maintain the rotor's rotation. So this is our Hall posture sensor feedback give to the motor to rotate the rotor part of the brushless DC motor. So next we are going to enter the speed control methods. So speed control of a brushless DC motor through voltage changing. So it involves adjusting the applied voltage to the motor phases to regulate its rotational speed. So by changing the voltage value, we have to effectively control the back EMF and also current in the motor windings, and motor speed also we have to control. So here how the process works. So here I will choose amplitude voltage is a 200 volt. So let's run this Matlab Simulink. Now, so this is our rotor speed 1851. Now I have to change the value of the voltage. So I have to put the value as a 500. Now we will run this simulation. Let's see what will happen. So again, it's beyond 3000 RPM. So that means 4485. So this is our speed. Now we have to reduce the voltage value. Now what will happen? So the speed will be reduced. So this is our voltage control of the brushless DC motor. So to control the motor speed, you can manipulate or change the voltage that apply to the motor phases. By changing the voltage, you can affect the balance between the applied voltage and also the back EMF. So which influences the current flow and there's the motor torques and the speed. So increasing the voltage above the back EMF level means that will result in a higher current flow through the motor. That will leading to increase the torque and faster acceleration also. So this is our speed control method of a brushless DC motor. Overview about this Matlab simulation project has been explained here. So to get more information about this project and Matlab files, contact our Pantech e-learning channel from the description box below. Thank you for watching this video. We also provide free webinars and free classes and various courses on various domains. To get more information, subscribe our Pantech e-learning channel and get updated notification daily. If the concept was explained is useful and informative, give like and share. Comment your feedback in the comment box. Thank you once again.